Hey guys, it's me again. Hope all is well. Today we are going to compare populations. To do this, we need to know how to do the box plots, which was yesterday's assignments, and I went through it all. You also need to know about your dot plots, which again we've already done. So let's look here. This is a box plot. How many times have you exercised this month? These are going to be those 5 numbers, or actually here they have more numbers. So we have our minimum, we have our maximum, we have our first quartile, we have our third quartile, and then here they did some ranges. The range we know is our highest minus our lowest. So when I do 30 minus 0, it gives me 30. The interquartile range is actually looking here. So 20 minus 5 gives me 15. Okay, what is the median? Here is the median right here. I know that the median is the middle number, so that represents half of the data, or 50% of the data. So when we were going through the box plots yesterday, we talked about your quartile 1 is 25% of your data. The median is 50%. The upper median, or your Q3, is 75%, and all the way up to the max is 100%. So what inference can you make from the box plot? So when I look up here, there's lots of different things, but I can say 25% exercise between 5 and 10 times, because that represents 25% of the data. I could say that 50% exercise between 5 and 20. I could say 25% exercise from 0 to 5. So there's lots of different inferences you can look at, but you have to know that information from that box plot. So we're going to actually compare 2 different ones at the same time. So there's 3 things that you're going to have to know. We're going to have to know the shape, the center, and the spreads. So the measure of center, if they are symmetric, we use the mean. If neither is symmetric, we use the median. And if one is symmetric and one is not, we use the median. The measure of spread is your interquartile range for all 3. It doesn't matter if they're symmetric or not. So you're asking me, what is symmetric? Let's look right over here. Symmetric is our shape, okay? When you look at symmetric, if you were to fold it in half, both sides would be the exact same. So here's my half. If I were to take it and fold this over, they match up perfectly. That's symmetric. Here is my half. If I folded this, they would not be symmetric. So this is our shape. This is our center. This is our spread. So that's what we're going to be looking at for all 3 of these. So in our first example, example 1, when I look at my shapes, that's the first thing I'm going to look at. Neither one is symmetric, so my shape is not symmetric. So then I have to find my center. Remember up here, to find center, if neither is symmetric, you use your median. So I look for math, my median was 10. For science, my median was 20. So my spread for math, you did your 20 minus 5, your interquartile range, and it was 15, and for science it was 10. So since neither is symmetric, 75% of the math class data is greater than 5 texts. So here's 5, 25, 50, 75% text 5 or more times. So then when I look at science, 75% or 15 or more times. So, excuse me, use the median to compare the centers and the interquartile range to compare the spreads. So overall, science class students sent more text than math students. The median for science class is twice the median for the math class, the 20 and the 10. There's a greater spread of data around the median for the math class than the science. So there's a greater spread here than here. So those are just a couple of inferences that you can make from that data. So now we wanted to do it ourselves. It says the double box plot shows that most MP3 players at 2 different stores. You're going to compare the shapes, centers, and spreads. So when I look, neither one are symmetric. So if I were to do my measure of center, since neither are symmetric, we're going to look at the median. So for Electronics World, my median is 70. For Bargain Basement, my median is 60. My interquartile range here is 10. My interquartile range here is 10. So what is a couple of inferences I can make from this? I can say 75% of the MP3 players at Bargain Basement are less than $65. And I can say 75% of Electronics World are greater than $65. So if I were comparing and say, where do I want to get my MP3 player, I would probably say Bargain Basement, because the majority are going to fall under the $65, where here the majority fall above $65. So now we're going to compare 2 dot plots. Here's our dot plots. Okay. If I look at them, again, let's look at their shape. This one, if I were to fold it in half, is going to match up. This one as well. So both are symmetric. So use the mean to compare the centers, and use the interquartile range to compare the variations. So when I look at these, my interquartile range for Springfield is 3, for Lake City is 3. So while both cities have the same variation, which means they're both symmetric or spread of data, Lake City has a greater temperature than Springfield. So if you look up here, 50% of the data is above 85. Up here, 84. 100% of the data is between 84 and 78. So these have higher temperatures than Springfield. So when we do it by ourselves, we're going to look. Neither one of these is symmetric. So the mean for up here is 35.5. The median is 35.5. And the range is 5. Median 32.9. Median is 32 and range is 8. So what inference can I make? I'm going to say neither is symmetric. Annika has a greater spread. Pedro has a greater average. I would infer that Pedro has more emails. So if you look up here, that could be your inference. Okay, here's my next set of data. I want you to notice this little dot way over here. This is our outlier. We've talked about outliers before. It's that one thing that can skew all of your data. So let's look. This is not symmetric. This is symmetric. So median is 70, interquartile range is 30, median is 50, interquartile range is 20. So overall, Treetop Tours has a greater number of daily participants. So if you look up here, it's a greater number. However, it also has a greater spread or variation. So it's more difficult to predict how many participants they may have each day. Zip Adventures has a greater consistency, if you notice, because it's symmetric, it's more consistent. Again, they compared 2 dot plots. The median was 8, 2, 8, 2. So they're the same for both sets of data. However, the interquartile range for Angel's number of hours worked is different of 10 and 8. While up here, it's a difference of 9 and 7. So Angel typically works more hours per week. So we do ourselves. This one is symmetric. My range is 4. My median is 18. Not symmetric. Range is 9. Median is 17. The inference I'm going to make is Martin typically runs faster, but Kareem is more consistent. So this shows more consistency. He varies. You can see how much greater the spread is here than it is here. So, looking through our guided practice, symmetric, symmetric, so they're both symmetric. The mean for second period is 16. The mean for fifth period is 17. The range is 4, the range is 6. So fifth has a higher average, but grades are more spread out. So whereas their average is higher, it's not as consistent as it is here. Comparing the box plots, symmetric, not symmetric. So you notice again here, there's that outlier. So Hayes Road is more consistent. It's centered around a higher value. Here's the higher value. So, because that's my center. That is it on comparing two box plots and two dot plots. And you can look at the notes and then complete your assignment. Have a great day.